Gilli Pong.
Hello and welcome to Gilli Pong analysis. We're working on reading a book called How to Lie with Statistics by Darrell Huff. And we are on chapter 4, I believe. And let me see, where was that? Yep, chapter 1. Okay. Chapter 4. Much ado about practically nothing. If you don't mind, we will begin by endowing you with 2 children. Peter and Linda, we might as well give them modish names while we're about it, have been given intelligence tests, as a great many children are in the course of their schooling. Now, the mental test of any variety is one of the prime voodoo fetishes of our time. So you may have to argue a little to find out the results of the tests. This is information so esoteric that it is often held to be safe only in the hands of psychologists and educators. And they may be right at that. Anyway, you learn somehow that Peter's IQ is 98 and Linda's is 101. You know, of course, that the IQ is based on 100 as average or normal. Aha! Linda is your brighter child. She is furthermore... can you help me here? Above average. Peter is below average, but let's not dwell on that. Any such conclusions as these are sheer nonsense. Just to clear the air, let's note first of all that whatever an intelligence test measures, it is not quite the same thing as we usually mean by intelligence. It neglects such important things as leadership and creative imagination. It takes no account of social judgment or musical or artistic or other aptitudes, to say nothing of such personality matters is diligence and emotional balance. On top of that, the test most often given in schools are the quick and cheap group kind that depend a good deal upon reading facility. Bright or not, the poor reader hasn't a chance. Let's say that we have recognized all that and agree to regard the IQ simply as a measure of some vaguely defined capacity to handle canned abstractions. And Peter and Linda have been given what is generally regarded as the best of the tests, the revised Stanford Binet, which is administered individually and doesn't call for any particular reading ability. Now, what an IQ test purports to be is a sample of the intellect. Like any other product of the sampling method, the IQ is a figure with a statistical error. My mouth just broke. The IQ is a figure with a statistical error, which expresses the precision or reliability of that figure. Asking these test questions is something like what you might do in estimating the quality of the corn in a field by going about and pulling off an ear here and an ear there at random. By the time you had stripped down and looked at 100 ears, say, you would have gained a pretty good idea of what the whole field was like. Your information would be exact enough for use in comparing this field with another field, provided the 2 fields were not very similar. If they were, you might have to look at many more ears, rating them all the while by some precise standard of quality. How accurately your sample can be taken to represent the whole field is a measure that can be represented in figures: the probable error and the standard error. Suppose that you had the task of measuring the size of a good many fields by pacing off the fence lines. The first thing you might do is check the accuracy of your measuring system by pacing off what you took to be 100 yards, doing this a number of times. You might find that on the average you were off by 3 yards. That is, you came within 3 yards of hitting the exact 100 in half your trials, and in the other half of them you missed them by more than 3 yards. Your probable error then would be 3 yards in 100, or 3%. From then on, each fence line that measured 100 yards by your pacing might be recorded as 100 plus minus 3 yards. Most statisticians now prefer to use another, but comparable measurement called the standard error. It takes in about 2/3 of the cases instead of exactly half, and is considerably handier in a mathematical way. For our purposes, we can stick to the probable error, which is the one still used in connection with the Stanford Binet. As with our hypothetical pacing, the probable error of the Stanford Binet IQ has been found to be 3%. This has nothing to do with how good the test is, basically, only with how consistently it measures whatever it measures. So, Peter's indicated IQ might be more fully expressed as 98 plus minus 3 and Linda as 101 plus minus 3. This says that there's no more than an even chance that Peter's IQ falls anywhere between 95 and 101. It is just as likely that it is above or below that figure. Similarly, Linda has no better than a 50-50 probability of being within the range of 98 to 104. From this, you can quickly see that there is one chance in 4 that Peter's IQ is really above 101, and a similar chance that Linda is below 98. Then, Peter is not inferior but superior, and by a margin of anywhere from 3 points up. What this comes down to is the only way to think about IQs and many other sampling results is in ranges. Normal is not 100, but the range of 90 to 110, say. And there would be some point in comparing a child in this range with a child in a lower or higher range, but comparisons between figures with small differences are meaningless. You must always keep that plus or minus in mind, even or especially when it is not stated. Ignoring these errors, which are implicit in all sampling studies, has led to some remarkably silly behavior. There are magazine editors to whom readers' surveys are gospel, mainly because they do not understand them. With 40% male readership reported for one article and only 30% for another, they demand more articles like the first. The difference between 35 and 40% readership can be of importance to a magazine, but a survey difference may not be a real one. Costs often hold readership samples down to a few hundred persons, particularly after those who do not read the magazine at all have been eliminated. For a magazine that appeals primarily to women, the number of men in the sample may be very small, By the time these have been divided among those who say they read all, read most, read some, or didn't read the article in question, the 35% conclusion may be based on only a handful. The probable error hidden behind the impressively presented figure may be so large that the editor who relies on it is grasping at a thin straw. Sometimes the big ado is made about a difference that is mathematically real and demonstrable, but so tiny as to have no importance. This is in defiance of the fine old saying that a difference is a difference only if it makes a difference. A case in point is the hullabaloo over practically nothing that was raised so effectively and so profitably by the old gold cigarette people. It started innocently with the editor of the Reader's Digest who smokes cigarettes but takes a dim view of them all the same. His magazine went to work and had a battery of laboratory folk analyze the smoke from several brands of cigarettes. The magazine published the results, giving the nicotine and whatnot content of the smoke by brands. The conclusion stated by the magazine and borne out in its detailed figures was that all the brands were virtually identical and that it didn't make any difference which one you smoked. Now, you might think this was a blow to cigarette manufacturers and to the fellows who think up the new copy angles in the advertising agencies. It would seem to explode all advertising claims about soothing throats and kindness to T-zones. But somebody spotted something. In the list of almost identical amounts of poisons, one cigarette had to be at the bottom, and the one was Old Gold. Out went the telegrams, and big advertisements appeared in newspapers at once in the biggest type at hand. The headlines and the copies simply said that all cigarettes tested by this great national magazine, Old Gold, had the least of these undesirable things in its smoke. Excluded were all the figures and any hint that the difference was negligible. In the end, the Old Gold people were ordered to cease and desist from such misleading advertising. That didn't make any difference. The good had been milked from the idea long before. As the New Yorker says, there'll always be an ad man. Yeah, there'll always be an ad man. What's your decision? I like the second cup of coffee best. Charlie's Independent Laboratory. Yeah. So here concludes Chapter 4 of How to Lie with Statistics by Darrell Huff. Thank you so much for watching. Enjoy your present moment. And remember, it's time to shine. So, let's glow!
Gilli Pong.
Analyze this stuff.